So your foldable that you have should look like this. Okay, yours is just blue. Okay. Yeah. Yesterday,
Yes, sir.
Yesterday we did talk a little bit about what happens to your A, or what the A causes to happen in an equation. Okay, but we talked about it when it's in standard form. So ax squared plus bx plus c is standard form. What form are we going to be talking about today, though, according to the handout there?
Vertex form.
Vertex form. Okay. However, in both forms, the A, okay, like us here, okay, the A does the same thing, no matter which form it is in. The A still tells you the same thing.
Is that a 0 or an O?
That's a 0. So these right here are just bullet points. Okay, those are just bullet points.
Do we write them down?
Okay. Really?
What do these bars mean? Do you guys remember?
Absolute value.
Absolute value.
Yeah, I'm on it today.
Eh?
What? Wait, hold on, that sounded wrong.
No. What? So what does the absolute value bars tell you or mean?
That the graph. No, I'm being wrong.
The official definition of absolute value is the distance a number is from 0. Okay? The distance a number is from 0. Just like if we were to drive from here to Longview and we tell somebody it's 20 miles, we don't say it's negative 20 miles because we're going south, right? We just say it's 20 miles. And if we're at the store in Longview and we say it's 20 miles home, it's 20 miles home. We don't say it's positive 20 miles and a negative 20 miles because we don't do negative distance, right? So the absolute value is the distance a number is from 0. In other words, we don't care about the sign in front of it. We don't care if it's positive or negative. It's always positive, or just the actual value of the number itself without the positive or negative in front of it. Does that make sense? That's what absolute value means. So that's what this is clarifying right here. So the absolute value of A, just the number itself, okay, if it's greater than 1, then the graph is going to narrow. Okay, so your graph is going to look skinnier. Okay. So, okay, skinnier or squished, I think is the word I was using in the other classes. I was saying that it's squished. Okay, it looks squished.
Can I write with different colors in these boxes?
You can.
I'm gonna write
Now, if the absolute value of your A falls between 0 and 1, okay, if it falls between 0 and 1, then it's going to get wider. Okay? So it gets wider. So my graph for this one would look something like this. Be a really fat U, right? It'd be stretched out wider. So neither one of these care about whether it's positive or negative. We only care about the number itself. The negative sign comes into play here for this last one. Okay? If A is negative, then that means it's going to reflect vertically. So it's going to turn upside down. And that's what we talked about yesterday, right? If it's a positive A, it goes up, and if it's a negative A, it goes down.
Yep.
It's kind of cool to use these colors.
They don't like the same color. Okay.
So the vertex form, is this form that's written right here that you can see. Okay, f of x equals the a value, which we talked about what the a tells you. And then it's got parentheses. Notice it still has the square because we're talking about quadratics. So it's going to have the power of 2. Okay. When we talked about linear functions, they looked the exact same way, except we didn't have a power of 2, right? You could write them this way when you were talking about transformations. They just didn't have a power of 2. So that's the difference here between the quadratics and the linear, as the quadratics do have that power of 2. The same things happen though. Whatever happens inside the parentheses, affects the h. Affects the x, sorry. So this h is your x coordinate of your vertex. What happens outside the parentheses affects your y. Okay, so it is the y coordinate of your vertex. The other thing we talked about when we were talking about transformations of linear equations is that anything that happens inside the parentheses is opposite, remember? So when you see a negative h, it's actually positive. If you were to see a positive h, it's actually negative. Okay, so we'll do a few examples and that will clarify what I just said there if you were still confused about that. You don't have to. Since I'm not writing it as I go, I'm just trying to help point out what I'm talking about. Okay, so again, what happens inside the parentheses, so this stuff right here with the h tells you what happens on the horizontal axis or the x-axis, the horizontal shift. It's going to tell you how it goes left and right. Okay. The k deals with the y-axis, so it's going to tell you how it goes up and down, the vertical shift. Juan, head up for me so you can be taking these notes.
I am taking these notes.
Okay.
Yeah, take some notes.
So down at the bottom, this green graph right here is your parent function. Okay. So this is the parent graph, okay, for your quadratic graph. It always goes through 0, 0. And we'll normally see it as just f of x equals x squared. If we want to write it in vertex form, then we would see it as f of x equals x minus 0 squared plus 0. That's how the parent function would look if we wrote it in the vertex form. Okay, but we don't usually write plus zeros or minus zeros because they don't change anything, right? So the simplest form is written like that.
Wait, which one is that? Which graph is that?
That's the green one here. That's that parent function.
Like on the paper, which graph is that? Where's that?
It's on the front, at the bottom of the front. You don't have it. You have to graph it there. The parent function is not graphed on this one for you. All right, so it goes through 0, 0, and then the parent function goes up 1 over 1. and then it's mirrored on the other side. And then it goes from that point, it goes up 3 over 1, and then it's mirrored on the other side as well. And that's how you get your parent function. You can get Desmos to graph it for you as well and see the change that happens. Now the pink one that's there, it's this new equation that we have here. So the vertex is 1, negative 3. Why is it a positive 1, even though it says negative 1 right here? Because it's inside the parentheses, and we talked about it being opposite when it's inside the parentheses. And then negative 3 is there on the end. So that's your vertex down here at 1, negative 3. Is there a number here in front of the parentheses for my A?
1.
1. There's that invisible 1 there. Hmm? Now, if you go back up to what we talked about for the A, notice how none of these things included 1. It was greater than 1 and then less than 1, right? There was no or equal to 1. Because does multiplying anything by 1 change it?
No.
No. So 1 doesn't change the slope. Okay, it doesn't change the rate of change of your quadratic graph here. So your other points would do the same thing. So it starts at the vertex, up 1 over 1, up 1 over 1. So there's your next point, and it reflects on the other side. Then from here we go up 3 over 1, and it reflects on the other side. So there would be my 5 coordinates that I would write. And I'm only looking at how my vertex changed from 0, 0 to the new spot of the vertex. So its transformation was that it went from here, it went 1 unit to the right, and then it went 3 units down to its new location. We gave directions to the new location. Okay. Did you need something at the top, LaPierce?
Mine was pretty neat so
Can you see
far.
it?
Coloring in mine too.
So flip or open your foldable up to the inside.
Why flip it? It is.
Okay, you can.
Yeah, so now let's look at this very first one here. What is my vertex going to be? So it's got the parent functions graphed for you on these. What is it going to be, Gavin? I heard you say it. 2, negative 4. Okay, so the x value is this number right here, and its opposite sign. This one keeps the sign. So now when I graph it, my new vertex is at positive 2, negative 4, right here.
Oh my God.
Do I have an A that's going to affect anything there in front of the parentheses?
No.
No. So it's going to be the same way, up 1 over 1 and reflected on the other side. Then up 3 over 1. Okay. These 3 coordinates right here are the 3 that are going to tell you whether it gets wider or narrower. And so those are the 3 most important ones for you to look at and see. So how did it transform? What transformations happened? Okay, so it went right, and we do use right or left. Don't say over or back. Okay, so we say right, 1 or 2 units, and down 4 units. That's how it changed. It didn't get skinnier or narrower or wider or anything like that. So look at this next one. What's the x coordinate going to be, Jordan? What? Which one? Okay, remember inside the parentheses it's opposite. So if it's negative inside the parentheses, it's going to be positive 2. Okay, Preston, what's my y coordinate going to be?
Alrighty, the y coordinate's gonna be 2.
What's being added out here on the end?
Added
0. So it means I was right.
Okay. This right here is my A. It has nothing to do with my vertex. It has to do with my slope. It has to do with the wideness or the narrowness or whatever of the U shape. So my new vertex is going to be at 2, 0. So it's going to be right here. Now, when there's a 1 over 1 or a 1 in front right here for my A, then we go up 1 over 1 to get to this next point. If there's a 2 in front, and so it's 2 over 1, where do you think I'm going to go from this new vertex point? Up 2 over 1, up 2 over 1, and then I'm going to reflect it on the other side. So it's going to look like this. So it goes twice as many up as it goes over. So for this next one, if I had enough to graph the next one, it would have to go up 6 because it would be doubling how far it normally goes in over 1. Okay. So how does this one, what is my transformations for this one?
right 2 units.
Okay, right 2 units. Okay, and does it go down any? Nope.
So do you have to write anything, or do you?
Well, what does the A change? It gets narrower, right? It got narrower. Preston, put your phone up.
Good enough.
So for this next one, okay, Cutter, what's my x coordinate going to be for the new vertex for this one? What's the x coordinate going to be for this new vertex?
Not sure.
Is there anything being added or subtracted to that x inside the parentheses?
Would it be 1/2?
No, wouldn't it be 0, -4? Right.
It would be 0 for my x and -4 for my y. Yes, there's nothing inside here there's nothing inside with my x. Okay.
And you
Josh,
said
are
if
you
there's
writing all
something
this down too?
You said if there's something in there with the X, then it's the opposite of it?
It's the
Always?
opposite. Anything inside the parentheses when you're talking about transformations on a graph, it's always the opposite sign. Okay, so we know my new vertex is down here at 0, -4. What does the A tell me in front? This 1/2.
So it's gonna go up 1 and 2.
Up 1 and 2 over, then I'm going to reflect it the other way. Correct. Okay, from that vertex point. So like I said, those 3 points right there tell you or show you if it gets wider or skinnier. Okay, so this one gets super wide actually.
Oh, here it is. Oh my god, you're messing up, bro. How you put the
So what happened with my vertex? How did it change from 0, 0?
It went over 2 up 1. Or right 2 up 1.
no wider?
So it got wider. Okay, my vertex itself didn't get wider, but my graph got wider. What happened with my vertex?
It went 4, down 4.
Down 4 units. Yep. So that people can still get that one, I'm going to start down here at this bottom one.
So it'd be 1.
Can I try to find the X value and the Y value?
Okay, well, go ahead.
So I think the X value is going to be -1.
Okay,
And the Y value is going to be 2.
correct. So that's your new vertex.
Good job.
Okay. So -1 and up 2, so it's right there. What does this do to it, Mason? What does that negative sign out front do?
I don't know. Go down or something?
Instead of opening upward, it's going to open downward. So it's still going to have that same curve as the original one or the parent function.
And it either always goes up 1 over or down 1 over, right? Or no, not necessarily.
Well, because there's an imaginary 1 right there. So yes, those 2 points, if it's in this form, right, those 2 points just change however that changes there. So if it's a 1, it's down 1 over 1. So that only tells you for these 3 points, from the vertex to those 2. Does that make sense?
Yes.
Okay, because it's kind of like it's exponential after that, right? They get bigger and bigger. But yes, that tells you the change that happens right there for that very first unit from the vertex, without having to graph it on Desmos or the calculator or whatever, right? So what changes happened?
Left 1 unit.
Okay, so left 1 unit, up 2 units. It didn't get narrower or wider, right? It did what?
It reflected.
It reflected. Okay, so the negative sign makes it reflect.
Do we have get more math points over this?
Yeah.
Yep, this is the last lesson for this unit as well. So we will be testing over unit 7 and 8 next week. And review on Tuesday. Test will probably be Wednesday and Thursday, since we don't have school Monday. And Friday next week, they signed me up for something, so I won't be here in the morning.
Ain't there another Friday we get out sometime?
We get out a half day for Good Friday, I think, before Easter. Or we might be out the whole day But anyway,
Wait, is that spring break next
and
week?
then no, another two more weeks before spring break. Okay. Oops. Okay, Joshua, your turn. What's my vertex for this one going to be?
Positive 1 for X and 1 for Y.
Positive 1, 1. Yep. Okay. So, Juan, what does the A out front here tell me?
Right.
Well, that's what this number in front of the parentheses is called. So what does the negative 2 tell me?
Yeah, we're gonna go -2 to right.
No, it's going to tell me whether it's fatter or skinnier. So it's going to tell me if it's wider or narrower. So if it's greater than 1, is that going to shrink it, make it skinnier, or is that going to make it wider?
Wider.
It makes it narrower.
Yeah.
Because it goes up faster than it goes over. Okay. And this negative sign is going to make it flip. So instead of going up 2 and over, we're going to go down 2 and over 1 and reflect it on the other side. And it's going to look
So
like
after you
this.
get your points placed, that middle number out of the parentheses always determines what you're gonna do next. Your next move is.
Yes. So it reflected.
Yeah.
It reflected, and then what happened?
And it went down. It went down 2 units. And
Not from the vertex, it didn't.
it went.
Up 1.
It went right a unit.
Okay, right, 1 unit. And I heard somebody else say up 1 unit, right?
Oh yeah. It is.
And then there's one other thing that happened because we had a number that wasn't 1 out there in front. What else happened? It got narrower, right?
So it wouldn't matter if it's more narrow than the original one.
It does. That's why we say that it's got narrower.
Well, then doesn't that mean it's not reflecting anymore because they're different? Or just the way they're lined up?
No, it still means reflected. The negative sign out front here, this negative, means reflected. So this negative, if you see a negative right there, it's automatically reflected. The 2 itself makes it be narrower. So that A told you 2 different things, right? Okay, Abraham, ready to do this next one for us?
Yeah.
Okay.
Which one?
The very top one up here, because I was going upside down on this.
Okay, yeah. Okay, so our X is -3.
Okay.
Right, and then we don't have 1 out here, right?
Correct.
So it'd be -1, right?
Nope.
Okay, so it'd be 1.
Zero.
Oh, every
Right.
0, yeah.
There you go.
I give him
Yep.
an answer.
Yeah, 0, and then well, that's what I'm supposed to find.
Okay. So now what does this negative right there in front tell us?
That you're gonna.
Now we're going down, right?
It's going to be flipped. It's going to go down.
Yeah.
Did it make it narrower or wider or anything?
It made it wider, yeah.
Nope.
No.
It doesn't change anything if it's just the negative, other than it just flips it or it reflects it.
And that's all you have to do. That and like tell it what happened.
Yep. So it reflected, and then how did it move?
and it
Well,
stayed the same.
It moved left
Left 3 units,
and
and
down.
then it got
Right.
shit.
And it
Just left
reflected.
it.
And it reflected, and that's it. And that's the end of our notes, and that's the end of our unit.
This was a unit.
Everything we did this week was a unit. Yep,
So-
that's
so
it.
we're
Those
done.
three things on quadratic graphs.
I'm pretty sure it's the easiest thing I've actually understood in this book.
Oh, really?
It's lots of vocabulary, is really, and you need to know this vocabulary for the STAR test. Okay, so, so you still have 10 minutes of class left. So you have time to get more math done. There's 6 points for today. Think only 3 different types of problems, and you have to do each of them twice.
Are they over
Okay.
what we went over?
Over what we just went over.
Oh,
Yep. Okay. So,
Take your pencil, Abraham.
What?